Today I shall discuss about the substitution reaction, that is SN1 reaction. SN reaction. SN reaction means that nucleophilic substitution reaction. It may be defined is that when any group or atom of any reactant of organic substances is released by nucleophilic reagent. This is called nucleophilic substitution reaction. The substitution reaction of nucleophilic, the nucleophilic reagent are hydroxyl group, cyanide, ammonia, sodium ethoxide, and alkylamine, halogen. Halogen means that iodide, bromide, chloride, ityadi, etc. etc. These are all nucleophilic reagent, because these are all nuclear Ravar reagent, where electron density is deficient. The nucleophilic substitutions run towards that area. Nucleophilic substitution reaction, in the case of nucleophilic reagent, that is electron rich area or maybe electron large area. Where the electron deficient area, the nucleophilic reagent will be run there. That is called nucleus Ravar, and so that it is called nucleophilic reagent. Nucleophilic reagent may be hydroxide, that is hydroxyl, cyanide, ammonia, sodium ethoxide, acetate, alkylamine, halide, etc. Let us consider a reactant alkyl halide. This alkyl halide may be methyl halide, ethyl halide, that is, when carbon is 1, it will be methyl, when carbon 2, it will be ethyl, and so on. In this case, that is in the case of alkyl halide, the electronegativity power of halogen is greater than carbon containing compound, so that the electron sharing, which is form the covalent bond between R and X, the electron covalent bonding sharing electron shift towards halogen, so that halogen will be partial negative and carbon containing substance will be partial positive, that is will be carbocation. That is, at first this alkyl halide is converted into carbocation and halogen release here as halide. The releasing power of halogen is iodine is greater than bromine, and bromine is greater than chlorine, chlorine is greater than fluorine. That is, releasing power of iodide is greater than bromide, releasing power of bromide is greater than chloride, and releasing power of chloride is greater than fluoride, because the bond strength between R and alkyl halide the bond strength R and iodide is very low than alkyl bromide, and the bond strength of alkyl and bromide is low than alkyl chloride, and bond strength of alkyl chloride is lower than alkyl fluoride. That is, the rate of the reaction is greater than bromide, bromide is greater than chloride, chloride is greater than fluoride, and so on. That is, stability power of alkyl fluoride is higher, it highest than alkyl iodide. That is, the bond strength of alkyl and iodine is near about 200, 100 and 200, 300 and so on. Now we shall consider SN1 reaction. That is, SN reaction are two types, SN1 and SN2. SN1 means that nucleophilic substitution for unimolecular substances. That is, unimolecular, nucleophilic unimolecular substitution reaction, that is called SN1 reaction. That is where the unimolecular substances, its atom or any atom or group is released by nucleophilic reagent, that is called SN1 reaction. SN1 reaction is the unimolecular nucleophilic substitution reaction. Let us consider a compound Rx. Here Rx first converted into carbocation and halide ion. That is step 1. This is step 1. It is carbocation. This carbocation is attacked by opposite charge nucleophilic reagent, that it will be minimized, that it will be neutralized by RNU compound, that is SN1 reaction. SN1 reaction are containing two steps, but it is unimolecular because the rate of the reaction depends on the reactant only. So that it is called SN1 reaction. SN1 reaction happens two types, but its concentration, rates of the reaction concentration, rate of the reaction depends on the concentration of the reactant. So it is called SN1 reaction. As for example, methyl bromide, first converted methyl carbocation and bromide. This methyl carbocation attacked by hydroxide, which hydroxide come from aqueous sodium hydroxide, that is called methanol. This is the SN1 reaction. In the case of SN2 reaction, here consider a carbon (1 degree) alkyl halide, because in this case electron density will be larger, because here absence of methyl radical. If here any methyl radical, then electron density will be less, so that it will be faster and attack toward the backward of the carbon, then it will form a transition state. This is called transition state. This is then established by this may be hydroxide, then it will be hydroxide, and then it will be methanol, that is methyl alcohol. This is the SN2 2 reaction. SN2 reaction only one step, but here rate of the reaction depend on the concentration of the reagent and concentration of the reactant, so that it is SN2 reaction, that is biomolecular substitution reaction. Biomolecular substitution reaction is 1 degree is greater than 2 degree, 2 degree is greater than 3 degree in the case of SN2 reaction, and SN1 reaction 3 degree is greater than 2 degree, 2 degree is greater than 1 degree. That is SN2 reaction is the reverse of SN1 reaction. 3 degree, 2 degree and 1 degree means that when carbon attacked with 3 carbon, that is 3 degree alkyl halide, and 2 degree alkyl halide when carbon is attached with 2 carbon, that is will be 2 degree alkyl halide. When carbon is attached to 1 carbon only, then it is 3 degree, 2 degree, 1 degree. The rate of the reaction in the case of SN1 reaction, in the case of SN1 reaction, the first degree will be faster than 2 degree and then 3 degree. In the case of 3 degree, in the case of SN2 reaction, 3 degree will be faster than 2 degree, 2 degree is faster than 1 degree. That is SN2 reaction is the reverse of SN1 reaction. Thanks for all.